Have you ever thought about how far AI could go? Well, the answer just got a lot more exciting. There's a new AI model that's raising the bar for what artificial intelligence can do, and it's called DeepSeek Chimera. It's already turning heads because it's twice as fast and smarter than its predecessor. This AI breakthrough is challenging everything we know about how AI systems should work, and it didn't take the usual expensive and time-consuming steps to get there. The process behind Chimera is revolutionary, and it's ready to change the future of AI. Let's dive into what makes this model so extraordinary and how it's already ahead of the curve. The breakthrough, Assembly of Experts, AOE. Let's start with how this new AI model came into existence. DeepSeek, the company behind this development, didn't follow the usual route. Typically, training AI models is a huge process. It requires powerful GPUs, a lot of data, and countless hours of training to make sure the model understands how to generate accurate and insightful responses. But with DeepSeek Chimera, the team took a different route. Instead of training the AI from scratch, they used an approach called Assembly of Experts, AOE. What does that mean? Well, it's like taking the best pieces of several AI models and merging them together to create one highly efficient and fast AI system. They combined three powerful models, R10.5, 2.8, the original R1, and V30324. Instead of using traditional datasets and long training sessions, AOE allowed them to simply take the best parts of each model's weight tensors. These are the parameters that help the model make decisions, and combine them. Think of it like blending the best features from three different experts in a specific field into one super smart and efficient AI system. This technique made the development process much faster and cheaper because it didn't require retraining the entire model. Instead, the team used tensor algebra, a straightforward mathematical operation, to combine these models. This made Chimera ready in no time while keeping the operational cost low. Imagine creating a super-intelligent brain with 671 billion settings in just a fraction of the usual time and energy. It's like unlocking the potential of AI without burning through thousands of GPUs and hours of computing. How does Chimera work? So now that we know how Chimera was built, let's dive into how it actually works. One of the coolest things about this AI model is its ability to process words efficiently and quickly. Unlike other models that use all of their parameters for every single word it processes, Chimera only uses 37 billion parameters out of the full 671 billion. What does this mean? It's able to focus on just the necessary parts of the model for each word, making the entire process more efficient and faster. But how does Chimera know which parts of the model to use? Well, it has a built-in routing system. Think of this like a traffic light for the model's brain. It decides which part of the model should handle the task based on the kind of word it's processing. For example, out of 256 smaller expert models, Chimera picks the 8 that are best suited for the task at hand. This allows the system to cut down on costs and speed up response times by avoiding unnecessary calculations. It's like only using the necessary lanes on a highway when the rest are empty. The speed revolution. Now let's talk about Chimera's speed. Speed is one of the major areas where this new AI shines. When tested against the previous R10528 model, Chimera produced answers about twice as fast. This is huge because it shows that AI is not only getting smarter, but also more efficient in its use of resources. On top of that, it was about 20% faster than the original R1, which was already considered fast for its time. These speed improvements come from the combination of expert models, particularly from R1, which excels in reasoning, and V30324, which is optimized for more concise answers. This means Chimera can think deeply like R1, but communicate more efficiently like V30324. The results are truly impressive. In benchmark tests, Chimera was able to process shorter outputs without losing quality. In fact, these shorter answers saved a lot of time and reduced GPU costs. That's something AI researchers and businesses can get behind because the less time the model spends generating answers, the more cost-effective it becomes. But don't mistake speed for a lack of quality. Chimera still delivers the deep reasoning of R1 and the efficiency of V30324. What about the quality? Now, it's natural to wonder if merging three models into one might compromise quality, right? That's a fair concern. But the good news is that Chimera has been rigorously tested, and it passed with flying colors. In the MT bench test, it performed almost as well as the R10528 model, and in the GPQA Diamond test, which measures factual recall, Chimera performed somewhere between the two parent models. For math challenges like the AIME 2024 and AIME 2025, Chimera kept up with R1 in accuracy, sometimes even outperforming it, all while delivering more concise answers. It's the perfect balance between speed and quality. In coding benchmarks, Chimera continued to write clean code and follow instructions, thanks to the influence of V30324. This shows that even when merging models, the core abilities of each one remain intact. The real kicker comes when the engineers pushed the model's limits. They gradually increased the weight of R1 in the mix and observed what happened. When the influence of R1 crossed the 50% mark, the model started to generate tags. These tags were an indication of deeper reasoning from R1's influence. It was amazing to see how specific aspects of the model could be tweaked and changed with small adjustments. This showed how much control the engineers have over the AI's output, fine-tuning the model for perfection. To take things further, the team realized that they didn't need to merge everything from R1 and V30324. Instead, they focused only on R1's expert layers while keeping the V30324's routing systems, attention layers, and shared layers intact. This method preserved R1's smart reasoning abilities while maintaining the efficiency and speed of V30324. By doing this, they were able to create DeepSeek R1T2 Chimera, which was a game-changer in terms of speed and intelligence. It's compact, efficient, and doesn't sacrifice quality for the sake of speed. The model was released under the MIT license, meaning it's open source and can be freely used by anyone. By late May, it was processing 5 billion tokens per day, proving that it could work effectively at scale. The model's impact wasn't just theoretical. Early users on Reddit's Llama forum shared their thoughts, and the feedback was overwhelmingly positive. They found that Chimera was more grounded and reliable, with fewer hallucinations compared to R1 and V30324. The math workflows saw the most improvement, as the model maintained a clear chain of thought while cutting down unnecessary steps. Users were impressed by how well it performed in real-world tasks, and many considered it a true upgrade to previous models. The hardware behind Chimera. Of course, any AI model needs powerful hardware to run efficiently. The team behind Chimera tested the model on two different clusters, one using NVIDIA H194GB NVL cards, and the other with AMD MI325X 256GB boards. The results were clear. Chimera significantly outperformed its parent models on both setups. This means that no matter the hardware, Chimera is ready to deliver fast, high-quality results. Another impressive feature of Chimera is that it doesn't require specialized hardware like CUDA techniques to work. That makes it accessible and cost-effective for developers, researchers, and businesses looking to integrate AI into their applications. Environmental benefits. Let's take a moment to think about the environmental benefits of Chimera. One of the biggest challenges with AI models today is the enormous energy consumption that comes with training and running them. With Chimera's approach, only parts of the model are activated when needed. This means that fewer resources are used, leading to lower energy consumption. If you scale that up across millions of users, the carbon savings can add up significantly over time. The best part? The savings aren't just environmental, they're also financial. Businesses that rely on AI for real-time services will see major benefits from the reduction in latency. Less processing time means less cost and energy required, leading to lower operational costs for companies and more sustainable AI systems. AOE's role in AI's future. Looking ahead, the Assembly of Experts, AOE, is going to be a game changer in AI. This technique allows developers to mix and match different parts of AI models without retraining them from scratch. This makes AI models more customizable and efficient than ever before. Whether you need one model for coding, another for math, and another for language, AOE lets you build the perfect AI system for your needs. This flexibility could open the doors to smarter, more adaptable AI systems that are tailored to the needs of businesses, consumers, and researchers alike. It's not just about creating an AI model that works. It's about creating one that works better, faster, and more efficiently. So there you have it. Chimera is setting a new standard in AI, showing us what's possible when we combine the best of the best and let them work together in harmony. The future of AI is here, and it's faster, smarter, and more efficient than ever before. If you've got any questions or want to share your thoughts on AI's future, drop them in the comments below. Don't forget to like, subscribe, and stay tuned for more exciting updates.